In this video, we're going to consider multiplying radical expressions and also doing something at the end called rationalizing the denominator. So as far as multiplying, what we want to remind ourselves of is that if we take the nth root of a times the nth root of b, then that's going to equal the nth root of a times b. So if we see something like we have in part A here, and we want to distribute this through, first of all, when I multiply a radical times a number, it's kind of convention that we always put the number that's not in the radical in front of the square root. Okay. The reason that we do that, by the way, is if I put it afterward and I'm kind of sloppy about how I write this 6 afterward, then you leave the reader wondering, okay, is this square root of 2 times 6 or is it the square root of 26? And we don't want any ambiguity there. So that's why we like to put the number out front. And then square root of 2 times the square root of 10. All right, but remembering this property, we know that we can put these two together, right? And say this is the square root of 2 times 10, which of course is the square root of 20. Now we are responsible for making sure that our radicals are simplified, so we look for perfect squares, and yes, there is a perfect square factor of 20, right? 4. So we end up with this. So our final answer would be 6 square root of 2 plus 2 square roots of 5. Now, I want to just say that I was putting a lot of detail into this particular example. To be honest, I would be fine if in your own work you did not show me a good number of these steps. So like if you started here and then you jumped straight to here, I would accept that, right? I can, in your mind, doing the square root times the square root means I can multiply the numbers on the inside and get 20. I would be totally fine with that. And then, yeah, you want to make sure you show me that you understand 20 breaks down into 4 times 5, but then after that, I could see you skipping down to that final answer. So I'm showing a lot of detail there. You can skip a few of those steps as long as you're comfortable. All right, one like part B. Well, if I had given you something like x plus 8 times x minus 6, you would, of course, FOIL that out, right? Well, that's the same form this is in. So I'm going to have you FOIL this as well. So first would be root 3 times root 2. Outside would be plus 7. We'll put that first times the square root of 3. And then minus square root of 5, square root of 2 for the inside. And then minus 7 square root of 5 for the last. So all these ones where we can, we'll say 3 square root of 3 times square root of 2 is square root of 6. Square root of 5 times square root of 2 is square root of 10. And all of these radicands are different. And also, none of them have perfect square factors, right? So here's one where you really can't do any simplifying after you multiply it out. That would be your final answer because you can't combine any of those. All right, let's try one like part C. So notice I have the same thing I'm multiplying here as I FOIL. So first, again, first outside, inside, last. And as I do the first, it's root 5y times root 5y. So I could do this. I could say square root of 5y squared minus 2 square root of 5y for the outside plus 2 square root of 5y for the inside and then minus 4 for the last. Now, if you square a square root, I think even though we haven't formally introduced this idea, I think we can agree that anytime you square a square root, they should just kind of zap each other, right? Because square root undoes what a square does. So this is just going to be 5y. These two, though, you can combine. negative 2 root 5y plus 2 root 5y. Well, that's going to be 0. And so this one's interesting because you multiply these two expressions that have radicals, but in the end, you don't have a radical at all. And then one like this, just remember if you're being given an expression and you're being asked to square it, and it's a binomial, then make sure you write it out like this because it also needs to be FOIL. All right, so we're going to have the square root of 10 squared plus outside is root 10, root 14. Inside is root 14, root 10 plus the square root of 14 squared. Okay. So I square my square root and just get 10. Here, let's multiply 10 and 14. I get 140 in both of those square roots, and then I get 14. So right off the bat, I have some like terms, right? 10 and 14 are alike. They have no radicals at all, so I'll combine those into 24. These two can be combined into 2 square root of 140. But then lastly, don't forget, you need to check to see if there are perfect square factors in 140. And it does have a 4 in it. So it'd be 4 times 35. So it'd be 2 times square root of 4 times square root of 35. And of course, square root of 4 is 2, so 2 times 2 is 4. So it'd be 24 plus 4 square roots of 35. All right. And the last thing I want to show you here is something called rationalizing the denominator. Um, this is something that I guess is mainly so that you understand when you're doing some of your work later on, when you get into pre-calculus and calculus, so that you make sure you understand when an answer you get is actually the same as the answer that might show up in a book or um, on an answer key or something your instructor does in notes. So there's this idea that a lot of times in math, um, they like to write answers without square roots in the bottom of the fraction. Okay. I personally don't mind square roots in the bottoms of my fractions, but what let's say that in the future you're looking at some sort of answer in the back of a book and this is the answer you come up with. It's unlikely that the back of the book's going to have the answer look like this. They like to have it so that there's no square root in the denominator. So in order to get rid of the square root, one thing you can always do is multiply that square root by itself. And of course, that's only legal if you do that on the top of the fraction as well. And what that does is on the bottom, of course, you're squaring the square root of 2. So you just get 2 out of that. And then on top, you get square root of 2. So this is how answers would tend to be written, even though if this might be what pops out from the algebra or the problem that you're working on. So if you have something like square root of 3 over 5 and you're asked to rationalize the denominator, it just means write the denominator so that it doesn't have a square root anymore. In this case, we need to multiply by the square root of 5 so that there's no more square root in the bottom. So on the bottom there, you just get 5. And then on the top, square root of 3 times square root of 5 becomes the square root of 15. So that's what it would look like to have the denominator rationalized. Again, what's the main purpose of this? The main purpose is in the future, you get an answer that looks like this after you work your problem, and then you look in the back of the book and you see, oh, here's the answer. This idea of being able to rationalize the denominator will help you understand, like, oh no, I did the problem correctly. They just did this little simplification step so that there's no radical in the bottom of the fraction.